Welcome to today's deep dive. We're going to be diving into something that I think you'll find super relevant to how we all learn, especially in the world of science.
Yeah.
We're looking at this research article titled Comparing Classroom Enactments of an Inquiry Curriculum, Lessons Learned from Two Teachers. Now, the title might sound a bit jargony, but stick with me because the insights here are pure gold.
I agree. Yeah, this isn't just about like some abstract educational theory.
Right.
It gets to the heart of how even small tweaks in teaching can make a big difference in how well students actually grasp and apply what they're learning.
Exactly. So picture this. Two sixth-grade classrooms, both using the same cool hands-on science curriculum focused on simple machines.
Okay.
You might think the students in both classes would end up with similar levels of understanding, right?
It seems logical,
Yeah.
but as this research reveals, it's not always the case.
Right. The study focuses on two teachers, Jane and Linda, and how they taught a unit on pulleys. What they found is that even though both teachers covered the same material, the way they structured the learning experience led to some pretty significant differences in how well their students understood those core concepts.
Yeah, and one of the big ahas here is how these teachers approached connecting different activities.
Right.
Think of it like this. You can give students a bunch of puzzle pieces, the activities, but it's the teacher's role to help them see how those pieces fit together to form the bigger picture.
Okay, I'm intrigued. So how did these teachers approach this whole puzzle piecing thing differently?
Well, Jane was really intentional about encouraging her students to use their hands-on experiments with pulleys to generate their own questions before diving into the more theoretical stuff.
Okay.
For example, after letting her students try out different pulley setups, they might naturally start wondering, does the size of the pulley wheel make a difference in how much effort it takes to lift something? By starting with a hands-on experience, those questions become way more meaningful because they're coming from a place of genuine curiosity.
It's like that feeling you get when you're trying to solve a riddle. You're way more invested in finding the answer if you're the one who's stumped by it.
Exactly. Now, in contrast, Linda's approach was a bit more structured.
Okay.
She provided her students with a preset list of questions to guide their exploration. And while that's not necessarily a bad thing, it does mean students might be more focused on finding the right answer, instead of stepping back to consider the connections between those different concepts on their own.
So it's about finding that sweet spot between providing guidance and nurturing that sense of independent inquiry.
Absolutely. And this is where another key insight comes in. The power of connecting new knowledge to what you already know.
Right.
Think about it. Learning is a lot easier when you can hook that new information onto something you've already got stored in your brain.
Right, like building a mental web of knowledge. So how did Jane use this to her advantage?
Well, before they even touched a pulley, Jane had her students think back to their previous work with levers, another type of simple machine. She helped them see that a fixed pulley, the kind that simply changes the direction of your force, operates on the exact same principle as a first-class lever.
Okay, I can see where you're going with this.
Yeah.
So she's not just throwing a new gadget at them,
Right.
but helping them see how it relates to something they already understand.
Precisely. She might ask them, remember how a lever pivots on a fulcrum? Well, think of the point where the pulley attaches to the ceiling as the fulcrum. By making that connection to levers, she helped her students build a stronger foundation for understanding pulleys because they could anchor that new information to something familiar.
That's so clever. It's like learning a new language.
Right.
It's way easier if you can relate those new words and grammar rules back to your native tongue.
Yeah.
But it's not just about making connections, right? It's also about asking the right questions to guide students towards those moments.
You hit the nail on the head. While both Jane and Linda asked questions, their approaches differed in a way that really impacted how deeply students engaged with the material.
Yeah, exactly. Think about it this way. Imagine a group in Jane's class has just discovered that using more rope in their pulley system makes it easier to lift a heavy weight.
Right, like, good job, you figured it out.
Precisely. But Jane, she took it a step further. Instead of just confirming their observation, she used it as a launch pad for deeper exploration. She might ask, why do you think having more rope makes a difference? What's happening to the weight as we spread it out over a longer rope?
Oh, interesting.
Yeah.
This is prompting them to think about the why behind the what.
Exactly. And those kinds of questions push students beyond simply memorizing facts. It encourages them to think critically and connect those abstract scientific principles to something they can actually see and experience. Instead of just knowing that more rope makes lifting easier, They're grappling with concepts like force, distance, and how those things relate to each other. It's like that aha moment when you suddenly see how all those separate puzzle pieces click together to reveal the bigger picture. So it's not just about what they learned in that moment, it's about building those critical thinking skills that they can apply to any problem in any subject.
Right. Now, before we get into the nitty-gritty of the study's results, I'm curious what's resonating with you so far about these different teaching approaches.
Honestly, it makes me think about how I learn best. I know I'm way more likely to remember something if I can connect it to something I already know, or if I've had a chance to, really get my hands dirty, so to speak.
That's a great point. It highlights how important it is for educators to consider these different approaches and figure out how to create learning experiences that resonate with the way their students' brains are wired.
Absolutely. So now I'm even more curious to hear what the research actually revealed. What were the outcomes for students in these different classroom environments?
Well, the results were pretty telling. The study found that students in Jane's class, the one where activities were connected, prior knowledge was emphasized, and questions were used strategically, those students performed significantly better on open-ended questions and those concept mapping activities.
So it wasn't just about memorizing facts. They were able to take what they learned and apply it in new and different situations. They were able to connect the dots.
Precisely. They were building those mental bridges between concepts, which is essential for deeper understanding and flexible thinking. And it's important to note that this doesn't mean Linda's approach was bad or ineffective. Her students still showed learning gains, especially when it came to retaining factual information.
It's not a case of right versus wrong, but rather a matter of understanding the nuances and the potential impact of different teaching strategies.
Exactly. This study simply highlights that even seemingly subtle differences in teaching approaches can make a world of difference in the depth and quality of student learning.
It really drives home the point that teaching is so much more than just delivering information. It's about creating those light bulb moments and giving students the tools they need to become active learners.
Absolutely. And this is where those findings have some major takeaways for everyone, not just teachers. Think about it, whether you're a student, someone who loves learning new things, or even if you're trying to explain a complex idea to a coworker. Understanding these principles can make a world of difference.
Right. It's about making information stick, right? It's like the difference between just reading a recipe and actually understanding the science behind why certain ingredients work together. You might end up with something edible either way, but that deeper understanding can transform you from a decent cook into a master chef.
Exactly. And that's what this research ultimately underscores. It's a call to action for all of us to be more mindful of how we learn and how we can make those learning experiences richer and more meaningful.
So it's not just about cramming our brains full of facts, but about making those connections and really engaging with the information.
Precisely. And it starts by recognizing that even subtle shifts in our approach can make a world of difference in how deeply we connect with new knowledge, whether we're trying to grasp a new concept, teach someone else, or simply make information more memorable. These insights can be incredibly powerful.
It's been amazing to really break down these teaching strategies and see how they translate to better learning. It definitely gives me a lot to think about.
Me too. And I hope this conversation has left you with some new insights and maybe even inspired you to approach your own learning in a fresh new way.
I think that's the perfect note to wrap up this deep dive. Until next time, keep those mental gears turning, and remember, the most fulfilling learning experiences are the ones where we connect those dots and uncover those aha moments.